Hello, and thank you for joining us today. I'm Chelsea, the Group Managing Editor of Labels and Labeling. Today, I'm joined with Maxcess Group, which also includes RotoMetrics, Tidland, Fife, and Magpower. And we're here for a webinar that focuses on tension and precision die cutting in today's world of thinner liners, faster press speeds, and a changing workforce. In this 1-hour session, Maxcess will cover how tension and pressure specifically impact die cutting and how converters can optimize press and material performance. Today's session is presented by Maxcess Senior Product and Application Specialist, Cris Harper, and he's joined with Technical Sales Manager, Chris Slay. These experts, who combined bring decades of press experience, will explore thin film liners, the impact of pressure, and how to effectively use tension for optimal performance, as well as tips for improving productivity. Today's roadmap looks a little like this. Our experts will discuss their end-to-end expertise, address challenges you may be facing with liner, provide an overview of rotary tooling, and discuss tension's impact on tooling and production. Chris and Chris will end by offering some top tips and tricks for managing tension and tooling. We're going to end the session today with a Q&A with our experts, so be sure to tune in until the end. And just a quick bit of housekeeping, on your control panel, you should see a drop-down arrow called Questions. Here's where you can put any questions for Chris and Chris to answer at the end of today's session. And just a reminder, a recording of the webinar will be available to view after at labelsandlabeling.com. So thank you to Maxcess, and Chris, I will turn it over to you.
Okay, thank you, Chelsea. Welcome everybody. We appreciate you being here and hope to give you some information that will help here in the next hour. My name is Cris Harper. As she said, product specialist for Fife and Magpower here in Oklahoma City. I've been with the company, specifically Magpower brand, for 33 years, and we'll just do some basics here. So this is supposed to be we're trying to make this a technical presentation, not non-commercial here, but we do want to talk about Maxcess here on the first slide, just to better explain who we are, what we're about, and what we're trying to do to help you all. So Maxcess is a group of fairly popular brands that would be involved in your process that include Fife Web Guiding, WebEx, Components, and Valley Roller Companies for precision rolls. That's vacuum rolls, calendar rolls, idler rolls, rubber covered rolls. Magpower tension control, which is part of what we're going to talk about today. RotoMetrics for rotary cutting and print cylinders. Maxcess also has a Maxcess-based inspection system, which is going to include print inspection and also material inspection, and Tidland winding products and slitting products. So those are what we're offering. They're end-to-end solutions that are involved in a lot of processes, if not all of them. And that is a convenience for a one-stop shop to have those brands there. But the other thing that Maxcess brings is the expertise across these brands and processes because they affect each other. So you're not going to guide well if you don't have good tension control. And of course, today we're talking about how tension can affect your die cutting. So it's the expertise that Maxcess brings across the brands and how they affect each other that we can try to be more helpful in the big picture. So with that, we'll go ahead and get started. Next slide, please. Another thing that we understand is that Industry 4.0 is becoming more and more important. And what is Industry 4.0? Well, it's the Internet of Things. It's the ability to bring in information from the processes and the such into one location for analysis. So with all these brands and all these components within the machine and your process, whatever you're doing to the web, the one common thing that ties that all together is the web itself. So if we see something happen to the web at the rewind, we may see it all the way at the unwind because it's connected through the web. So for you to be able to better understand what's going on in the process, we can bring in information from each one of those systems and each one of those processes that is timed so that you can collect the data of what's going on in the machine, examine the data when you see something that you didn't like, what was happening at every point in the machine, so that you can improve the processes, so we can reduce scrap, reduce changeover. And that is something that we are continuing to build into all of our products as we continue down the line here. So our goal is to make you better, faster, and smarter. Next slide, please. So with that in mind, I'll go ahead and hand this off to Cris Slay. He's going to talk about the die cutting part, and I'll be back in a little bit.
Great, thank you, Chris. Again, my name is Cris Slay. I'm a technical sales manager with the RotoMetrics brand of Maxcess products based in St. Louis, Missouri. I've been doing this for 44 years now, and I go all the way back to when we used to receive orders via mail. So I've seen quite a lot of changes in the environment in the last 4.5 decades and continue to see these today. We understand that you face challenges, and we have established solutions, tooling, and expertise that we try to bring to the market and bring to you in order to help you with these challenges. Thin film starts with thin liner. And when you get into thin liners, you have to deal with the variations on very thin gauges, I want to say microscopic levels, because we're talking about tolerancing here that's in the millionths of an inch. And when you get to these very thin liners, any variation that can happen in the liner itself, in the tooling, or in the stack up in your machine can have an effect on your successful ability to convert this. As these thin films, et al., take into consideration thin liners, they have also got thin face stocks on them in order to keep the roll size and diameters down, more labels per roll, etc. In most circumstances, because of this thinner liner stock, you've got a lighter coat weight of the adhesive underneath this liner stock. And in most circumstances, again, this adhesive is tackier or more aggressive than what we were previously used to in the market 5, 10, or 15 years ago. This high tack can be detrimental to your converting processes in terms of how it builds up on the plates, how it builds up on your rollers, how it builds up on the dies. In terms of the dies, what we recommend is non-stick coatings such as our Roto Repel in order to give you a tool that you can use to clean this material off, or if it does stick to it, and if it does not stick to it, to keep it from sticking to it. Sorry, I guess I am a little bit nervouser than I thought I'd be, Chris. In terms of converting itself, converting is a physical process. We think about this theoretically in terms of clearances, blade angles, and blade shapes, but you really are pushing a blade through the material in order to convert it into a shape, typically a label of some type. And this requires maintenance of the equipment. It requires understanding of what heat and expansion will do. It requires understanding of the differences that short runs versus long runs, the effects they have on the equipment that you're using. And when you're going through these changes, these changeovers quickly, the use of adjustable clearance anvils in order to maintain and minimize the variations in what you're doing can also help to reduce the consumption and your waste that you are generating with these changeovers in use. Let's go to the next slide, please. There are many, many factors that contribute to die cutting. They can affect positively and negatively what's going on the press and what you're able to achieve. Web tension, Chris will go into in great detail, but we wouldn't be able to produce labels. You wouldn't be able to print flexo without tension control. The image layout can have a lot to do with how the die cuts and most specifically how it strips. If you can't strip your web, you're not going to be able to run. The better you can strip your web, the faster you're going to be able to run. Running speed and the speed that is required to be able to convert and produce your equipment, produce your product, is a combination of multiple factors that go in on the website, along with the stability of the machine that you're using. That stability in terms of the anvil, the die, pressure systems, side frames, all that go into the overall die cut system itself add to the stability. One of the things that we see regularly is cylinder deflection. If you have too small a diameter of a cylinder for the width of material that you're trying to convert, this can cause problems. It causes problems in the material, in the conversion. Different types of material will have different problems associated with them. We talked about thin film on the initial slide, but what about thick films? What about difficult to convert thick materials or through cutting materials? In all of these circumstances, pressure perform a critical function in terms of what we're trying to do. We have to hold the die together with the anvil roll in order to compress the system, hold it down firm enough so that we can have the blades cut through the face stock without cutting through the liner. But as soon as you apply pressure to a moving system, you generate friction. Friction causes heat. Heat, the increase in temperature, causes thermal expansion. We'll get more to this in a second. Friction is something that your operator can have a direct effect on. Best practices, including the use of barrel wipers and using the minimal amount of pressure possible in order to get a successful die cut, will minimize friction and give you the best possible outcome. Next slide, please. RotoMetrics Maxcess Hydrojacks, made in the USA, are specifically designed for this operation. We are constantly being bombarded nowadays with our need for data. By having a gauge on the system, it gives you an opportunity to have a data point. Just saying I've got low pressure on there or high pressure is not enough when we're looking for data-driven solutions nowadays. Being able to calculate the required pressure for a die cut and be able to dial that in on a gauge so that you know within 10 pounds that you're on the correct pressure for it, that you're able to record this, that you're able to communicate this, and that you can use this for understanding problems. If you see needles fluctuating, or if you operators are great at this and they see that they have to have more pressure on one side of the press than on the other side in order to get a successful die cut, all of these are problems that can be understood and analyzed using gauges, using the pressure gauging systems. We recommend these can be calibrated. They're calibrated when you receive them from us. And we recommend that you have these recalibrated every couple of years. Next slide, please. So, why? All of this leads to successful conversion. The materials that you're cutting, the tooling you're using, all of the variables that go into the system, the pressure that's being exerted, all of these are parts of what it takes to get you to successful converting. Successful converting is shown in the middle, the perfect cut. This gets through your face stock, your substrate, it gets through your adhesive, it gets down to your silicone barrier without cutting through the silicone barrier. If you're cutting too deep, especially on a paper liner, you can have all kinds of problems like migration of the adhesive into the paper fibers so that your label won't dispense. On film liners, you can cut so deep that the material will snap when it's going through the application process. If you're cutting too light, the other end of the equation, if you're cutting too light on the spectrum, then what you'll see is with a paper label, you'll see fuzzy die cuts. With a film label, you'll see delamination where you see flagging, or the labels lifting up with a matrix where you can't strip them away without stripping away good product because it's not die cut cleanly enough. So this is what we're trying to help you with. Successful converting is a combination of accuracy, die design, and the environment that the tools that the product is being produced in. Again, your operator's control of the situation, the use of gauging, tools that will allow you to use variation to your benefit, such as adjustable anvils, all of these sorts of tools play into giving you something to be successful with. Next slide, please. Things have changed in the last 4 years. Consistency really suffered with sustainability and the problems that we had with the global supply chain 2-3 years ago. We've stabilized now, and materials have gotten much more stable than they were, but we've kind of stabilized in a new normal. Yesterday's tolerances on dies, the clearances we use, the blade shapes that we used as die makers, they simply won't work in today's world. The die that you're purchasing from us, for example, is different than the die you purchased 5 years ago because of these constant updates and changes. Standardization to liner thicknesses like the 1.2 mil, the 92 gauge, and differences in paper liners have added to these challenges. Next slide, please. My point here is the mitigation of problems. And mitigation of problems requires adaptation. Requires adaptation of your tooling, of your techniques, and your best practices. We have to get the operators involved in partnering with us to be successful for you. Accuracy requires precision. The precision now is in microns or in millionths of an inch. The accumulation of error can be one of your biggest problems. And when we're talking about tolerances that we're working with dies, blades, blade shapes, and clearances that are 1/20th to 1/50th the thickness of a human hair, when we're talking about microns or millionths of an inch, then you can see that if we accumulate these tolerances, it's where the problem starts getting harder and harder for you to diagnose. I've mentioned it before, but notably, we're selling more adjustable clearance anvils than we ever had. They're pretty much available on any new press that's out there. The reason is it's a tool that's available to you, like any other tool, that can successfully help you to combat these variations and to help you to dial in some of these micro tolerances that you're facing right now. Next slide, please. I just spoke about accumulation of tolerances. As an example, magnetic cylinder technology can improve your flexible die performance by including tooling that has, for example, D2 bearers and journals on it, so that you have a material that is part of the unit itself that will minimize your compression, will minimize the problems that you will have with heat, and can help to stabilize your system, will cause the flexible die itself to perform better and to perform at its optimum condition. I've used the joke before that if I make a great steak, but if I put it on a moldy piece of bread, I've just got a moldy steak sandwich. If I use a good tool underneath my good tool on top, I'll be able to keep that accumulation of tolerances under control so that you can successfully convert your product. We have seen temperature changes in the 15 to 20 degree range, 20 degrees being enough to cause enough change in clearance because of the growth of the bearers on a die that it can cause the conversion to no longer be successful. Next slide, please. There are a number of factors that go into high-speed die cutting. Registration and tension. Tension is a primary principle in flexo printing. I mentioned it earlier. We just couldn't do it without tension and without the control of tension. These tension points and the guiding points, the guiding issues that we have. Guiding is one of those other tools that comes into play. The faster your press is running, the more that guiding has an effect not only on the manufacture of quality product, but in the generation of waste. The faster you're going, the faster those sensors and that table has to respond in order to keep your guiding in track so that you'll be able to keep in registry. Faster also means print registration issues and die cut registration issues. Vision systems will help with this. Updating vision systems. I've seen a lot of energy in the last 2 or 3 years in the advances that have happened in camera systems and vision systems, and how cost effective they have become with some of the new products that we've developed, and how much more you're able to get, more bang for your buck, if you will, just in the last 2 to 3 years. Lastly, and I will always talk about this because the operators matter, and what your operators are doing matters, and lubrication matters. Lubrication, lubrication, lubrication. Using barrel wipers, making sure that you're running at the least amount of pressure possible in order to execute your die cut accurately, and maintaining the maintenance of the machine on a regular basis. Okay, let's go ahead and go to the next slide. I think we've got a question.
We do, thank you. So the first poll question, we will ask the audience to please select an answer below. Can the diameter of the stripping roll influence press speed? Yes, no, or I don't know. We'll give you a couple seconds as the answers are rolling in to please click a response before we close the poll. We'll give it about 10 more seconds because we're seeing them roll in over here on our end.
Oh, good. At least people are listening.
They're definitely here, and questions are coming in. A quick reminder, if you have more questions, you can find that drop-down menu to put them there. I'm going to go ahead and close the poll, share the results here. 83% said yes.
Oh, wow. Well, we've got a bunch of smart guys here, don't we? Let's go to the next slide, please. You're absolutely correct. The diameter of the stripping roll in relation to the shapes that you're trying to strip can absolutely influence the speed in which your press can run. Rules of thumb can be as simple as small shapes, small roll. A small diameter stripping roll will create more of an edge, if you will, and will actually give you a kind of dispensing action so that you've got a break where the web is coming away from your part as rapidly as possible, and that snap will help to keep the label down on the web. Conversely, for larger shapes, you want larger rolls. A 3-inch diameter or 6-inch diameter roll, like what you would think of for a boot shape or a jug label or something like that. That slower transition of the web of the waste coming off of the web will allow the adhesive that is underneath the label to do its job to help you to hold that label down in place. We've developed tools that will help also in terms of, we've got a product we call the Easy Clean Idler or Easy Clean stripping roll, which is a combination of a small diameter roll with rotor repel on it and O-ring. This will help to facilitate tension stripping, in which you are applying higher tension to the waste material, like with thin face stocks, so that you can pull those apart and use the O-rings on top of where your labels are to hold the label down and stretch and pull that waste up between those O-rings and get you a better pop, a better strip. Finally, I want to bring your attention to this picture. This picture shows that the web is being wrapped around the anvil roll. Wrapping the web around the anvil roll improves a number of different features in your die cut. The contact of the web against the anvil roll will help to stabilize that web and give the tool, the die, a better surface for it to be able to cut against. Also, being able to come down on a strip and apply a stripping angle like this against your roller will help with the stripping activity. I'm going to go ahead and stop. I've talked awfully quickly here. My email address is going to be shown in the last slide here. I know Cris and I will both stay on here as long as they will let us to answer your questions. But if you have any questions, comments, concerns, anything, please feel free to email me directly. I'm happy to take the time either to respond via email or to have a quick telephone conversation with you. Have a great day. Cris, it's up to you.
All right. Thank you, Chris Slay. So we'll talk about tension a little bit. It's kind of interesting. Tension control tends or can be the most overlooked aspect of an entire machine, mainly because if it's working properly, you'll forget about it. That's the goal. So some of our products, tension control, guiding, some of the winding products, that's what I call web delivery. We're just trying to get the web to the process in the proper spot at the proper tension so that whatever you're doing to it can be done consistently and to your spec. Other things like the die cutting and slitting and other things, those are actually part of your process. So tension control is the web delivery of it. And again, we want it so that when it's working properly, you'll forget about it. What you'll find when we're talking about the changing materials, the thinner materials, is that a machine that may have been working the last 20 years just fine, I'm picturing at the moment printing with die cutting at the end. I'm also picturing maybe a lamination that happens to the top of the web after the print before the cut. This machine may have worked fine for 20 years, and now all of a sudden you're starting to see some issues at the die cut, let's say. And that can be because what used to be, I don't know, 40-pound weight paper is now 15-pound weight, or their films, as Cris was saying, that are getting thinner and thinner, and they're becoming more stretchy. Those are things that will cause a machine that has been working to need to be looked at again and possibly upgraded in some cases. And that's kind of what we're going to talk about here. Those thinner webs, those stretchy, really what we're talking about is stretch in the material before the die cut. That's what we need to prevent. Issues that you'll see when tension isn't correct is what we're trying to show some of these here on the picture is that you're printing the material, the stars in a line there, but at the exit, they may be moving left and right between those. And that's because we have pre-stretched or stretching after the die cut, the material itself. We talk about registration, and registration can be affected by tension. I would expect that maybe the material, the images that are printed would be elongated, which is another issue if we're affecting registration that way. The two things that we kind of look at for registration issues is tension, which is stretching, or timing or phase, and that is really what we're talking about for tooling. So if we're die cutting a shape around the star there and the star is not always in the center, or let's say it's consistently not in the center, that may be because you have a gear issue between, let's say, the printing press and what's driving the die cut. If that's a line shaft, then we have, normally there's differential that lets you affect the strike of the die cut versus the print. Or if they're all servo, then there needs to be adjustment in servo. So tension can't fix all registration issues if that is a phase or timing issue. If it's because we're pre-stretching the material, then that becomes a tension issue that we can look at. Other complaints or things that you'll see is, again, the warp to text. The material on the edge there we're showing at the exit is wavy, and that's because we're deforming the material. Part size will vary if we're not having the correct tension, or even part curl, especially if you're laminating on top before. The tension in the material in a lamination compared to the tension on the material that was printed, or if you're a different process, we're laminating two materials together and then die cutting. Those tensions are very important, whether they're equally matched or equally offset, so that we don't curl the material later. So that's after the die cut. Maybe the next process where it relaxes is when you'll see some of this stuff come back or start to look bad. It may look bad immediately after it's stretched, or you may not see it until the next process. But those things can be fixed with tension, and that's what we'll talk about. Next slide, please. In reality, those tension pre-stretch is possibly coming all the way from the unwind, or it could be happening at the rewind after, which we'll talk about both briefly. So we're just going to talk about tension control in general. On an unwind, let's just start there. The tension that is in the material is a relationship between the torque that we're applying with the brake there on the center shaft divided by the radius of the roll. And that is a strictly proportional relationship. So when I have half the diameter, I need half the torque to maintain a constant tension in the web. And There's three basic ways to do that. Well, we'll call it categories to do that. All three are doing the same thing, which is actually turning down brake torque as the roll gets smaller to maintain constant tension, but each one is progressively more precise. So we'll talk about that. So the first category is manual systems. That means that literally it's a brake with a knob, and as the roll gets smaller, my operator is turning down the knob. So my operator is feeling the web or looking at the process, and it's his judgment that is setting where the brake is set to put the tension in the material. It's also, excuse me, up to the operator to make those adjustments as the roll gets smaller to try to maintain that tension. And how tightly they have to do that depends on the process itself and how tightly the web tension has to be controlled to keep the process consistent. So that output, as we note here, is influenced by the operator, and it's heavily involving the operator, which is a problem, right? We would like to have them concentrating on the process itself. They're out there, they're the lowest cost of install, and that's why they're still out there. The issue is if the operator doesn't make those adjustments or if he walks away, your tension is going to change. In fact, it's going to go up as the roll gets smaller if they don't change it. So an example here, an analogy for super beginners, an example of this would be a car or truck here, I should say. We're keeping the gas pedal in the same position as we go up a hill. That truck's going to slow down. I can adjust. Another example of the operator making the adjustment based on his eye or his feel or her feel is that it's an estimate. And some operators are going to be better at that, or drivers are going to be better at that than others. So there's inconsistencies from operator to operator, shift to shift. So we want to try to improve that, and that takes us to the next phase. Next slide, please. The next category is open loop control. So now we're actually adding a sensor for the roll material here. We're going to add a diameter sensor, measuring that diameter in the unlined. The diameter measurement goes into a controller. Our operator is setting a set point of output. So let's say at the beginning of the roll, they're still going to feel the web. It's still going to be their judgment on what the tension should be. But once they set it at one known diameter, then because we're measuring the diameter, we will proportionally change the output as the roll gets smaller to maintain that tension automatically. So now this frees your operator up to go do other things. So this is a good way to automate the process, but there are things that make it not the most accurate. If we have nonlinearities, let's say in the brake itself, like a pneumatic brake that we're showing in this picture, when you run faster line speeds for a known air pressure going in, it will actually transfer a different amount of torque. So your tension will actually be slightly different with speed changes for the same setting. The controller doesn't know that. So the controller is always going to just control the output proportionally. It would still depend on the operator to make that adjustment. So there is a better way to do it, but this is at least a good start. So this is our analogy here with the truck. The truck would be have a sensor on it that is measuring incline. And there's a formula in there that says when you have a certain amount of incline, it's going to change the gas pedal a certain amount. The problem is that it doesn't know whether the truck has nothing in the bed or it's loaded, has a load in the bed, so that there's going to still be some variance. Again, nonlinearities. Another example I would use is we've got a flat tire. It's going to take more gas to maintain that speed, and the controller doesn't know that. It just knows the angle of the hill. So next slide, please. So the last category and the most precise category is going to be closed loop systems. So an example with the roll here, we're actually putting a set of load cells or tension sensors on an idler in the machine so that we can actually measure the tension. That measured tension goes to a controller where the operator has set a tension set point that they want to run at. And we will change the brake as the roll changes diameter to maintain a constant tension by measuring the tension itself. Obviously on the truck here, that's cruise control. But when we talk about closed loop systems, this gives you consistency then from operator to operator, shift to shift, and is your most precise way of controlling tension because we're actually measuring it. It also compensates for those nonlinearities I was saying. if we have line speed changes now and the torque transfer does change, then it will read that and compensate for it automatically. That's why it is one of the more precise ways to do it. The other thing I wanted to mention before we go to the next slide is that we're actually showing a mag particle brake here. That's something that we like to use when we can. It has less issues. It's torque constant, regardless of that speed of the web. So that can make things easier to control also. And this can become a factor, and these control methods can become a factor when you're winding up your matrix scrap. Again, as the web and liners become thinner, you may have issues where you're starting to break the matrix where you didn't before. It's already a challenge because you have a small amount of material that you're winding. So you may have to look at controlling that where you didn't have to before. And mag particle might be a way that we want to do that there also. I'll also mention on this slide that in some cases, another version of closed loop system is dancer. So load cells here will have a dancer on the unwind. We use that for processes that are starting and stopping a lot, or if we have out of round rolls, which can be either a roll quality issue or it can be because clamp trucks are squeezing that round roll and making it egg-shaped. Dancers accumulate material and make it easier to compensate for that than a load cell reading it. So in some cases, dancer control is what you're going to want to use, and both of those are closed loop systems. One's controlling position, one's controlling the actual brake tension, but both of them will achieve a constant tension that you're needing. Next slide, please.
Okay, let's see how closely everyone's been paying attention. Time for a pop quiz. What is the most precise control loop option for controlling tension? We'll give everyone a little bit of time to answer as the, oh, you guys are quicker this time. You were ready for this question. We'll give it about maybe 10 more seconds before we close the poll and share the answers. And they get their grade from Cris. All right, thank you everyone who voted. The results are in. 85% say closed loop.
Okay, that's good. Yep, so like I said, the open loop control will be one notch better than manual, and closed loop control will be the best of all three. So that's good. We'll go ahead and talk about rewinds now. So we're done die cutting, and now we're just taking the processed material and we're winding it up, and we're kind of now focusing on creating a good package, as we would say, a roll that you can take off the machine. It's wound well enough that I can handle it and move it on to the next process in the factory, or it needs to be packaged and shipped to the customer. So our focus now is on that good package. And interestingly enough, if you'd use closed loop control on the rewind and you do everything as best as you can, and you're maintaining a perfect tension, you can still have problems. We can still see some issues that come up on a rewind, and there's a reason for it, and there's an easy solution to it. So some of those here on the first section, it's telescoping. So that is where the material, the center of the roll is actually squeezing out, and we'll talk a little bit more about why that's happening, but a lot of customers think that that is a guiding issue, and more times than none, it is a tension issue. Crushed cores. So again, we're talking rewind. So I put a fresh core on my air shaft, inflate my air shaft, wind up my roll, and when I'm going to remove it, I take the air out and the darn thing won't move, and that's because the core has actually been crushed onto the shaft, so crushed core. Starring, so we're kind of showing starring here on this picture on the right. Sometimes that's actually going to look like straight striations coming out from the center of the roll. That is a sign that the material layers near the center are being crushed and crinkled, or we've got layers sliding on each other, so that's called starring. There's also something called dishing, which is similar, but dishing is where your roll is shifting. If it was straight when you started, and by the time you get to full roll, not only is your material looking like it's telescoping, but the inside part that was straight now isn't. Okay, that's called dishing. So all three of those things can be dealt with the same solution. Next slide, please, Eva. It's called taper tension. So what's happening on your rewind is that the tension in the web is actually being converted into inward forces. And the larger the circumference of the roll, the more inward forces that we have acting in towards the center of the roll or the shaft. And it's those forces that cause these other problems. Obviously, with a crushed core, it can only take so much force until it will collapse at some point. Not super common, but it does happen enough. The telescoping that I was talking about, a coworker of mine, his example is you've got a wet bar of soap in the shower, and if I squeeze it really hard with my hand, am I going to crush the bar? No, it's going to squirt out of my hand because it's slippery. That's what's happening with telescoping. We're actually squeezing so hard that the inside of the roll is actually squeezing out. We can actually see that, I think we mentioned that in one of the slides here, but if you've got a material with adhesive on it, we've actually seen the issue so bad that the adhesive is being squirted outside, okay? So all those things can be fixed with taper tension, and taper tension is we're actually, as we start with a higher tension at core, and we reduce the tension set point as the roll gets larger. So an example would be if I'm starting with 20 pounds of tension at core, we may only be aiming for 15 or 12 pounds of tension at the full roll diameter. So we're reducing the web tension to make more consistent the inward force. And that in itself, which is normally a dial-in number you can use on your tension control, depending what type you're using, will fix all of those issues and done fairly quickly. 10 to 30% taper tends to fix most of those issues. There are extreme cases on more exotic materials, but and those can be affected by line speed with air entrapment. Those can be affected by the type of material you're running, how slippery it is, what kind of coating's on there. So what tells you need it? It's maybe not predictable till you start running material, but that would be the solution, taper tension. I think that's all I can think about talking about today for that. So we'll talk about some tips here. I'll pass it back over to Cris Slay for a minute.
Unmute myself, thanks. And unfortunately, I think that I had spoken about these first couple already when I talked about stripping, because stripping is so important to what goes on in the press in terms of speed. But again, to reiterate, use of a large diameter idler roll for stripping large die cut shapes. These would include bottle labels, jug labels, the boot type shapes, those irregular shapes that will have large areas that need to be stripped away, in which you're going to have to be able to exert enough pressure, enough force on the waste matrix itself to be able to pull that adhesive away from the liner. And then again, stripping small labels using a small diameter roller to help dispense those labels out of the web. Cris?
Okay, as we talked about, for indexing applications or out around rolls, probably need to use a dancer. Some people really hate dancers, but there's reasons for that, and I'd be happy to talk to you about it. And I love dancers, and dancers are, when they're necessary, use them. When they're not necessary, that's fine. Load cells are easier to install than a dancer, but definitely when you need a dancer, you need a dancer. Always isolate load cells from the plane change. Yeah, so on that unwind, I maybe should have showed that in the picture, but when you put a set of load cells in an unwind, we need an isolation roll between the unwind and the load cells themselves. We do want the load cells close to that unwind roll because you want the thing that you're measuring as close as possible to the thing that's controlling, right? So with tension, we're measuring and controlling the brake there. But we do need an isolation idler so that the wrap angle around the load cell stays consistent. As the roll gets smaller, it actually will change the angle of the web, and we just want to make sure that that's not affecting the sensor itself. So just one isolation roller between there. And then the last thing here, torque control is preferred to speed control. We talk about that a lot here. That is true for load cells. Speed control when we're using a dancer is not a problem. In short, torque control, you have a direct proportional relationship between the diameter of the roll and the torque of the brake. And it can be torque of a drive in torque mode. It can be the torque of a differential shaft on a rewind. but that proportional relationship makes it easier to control tension, and there's a lot less factors as you do with speed control. When you do speed control, it's possible. We do it every day, but there's a lot more factors and a few more sensors that you need to bring in, so it's more difficult. So torque control when you can, but we can talk speed control if that's what we need to do. And I think that's it for the tips.
Amazing information, guys. Thank you both so much. Now it's time for the Q&A. There are some questions. Some of you have found the question box, but if there's more, now is the time to put them in. Let's start with you, Cris, Harper, because you just kind of mentioned one that one of our viewers had, but when would they use a dancer versus a load cell?
Okay, so yeah, the first one would be indexing. So if your process is pulling the web in, we're doing some process to it so that the unwind stops. We bring it in, the process stops again, and that can be done really fast where the unwind maybe almost doesn't stop, but the web is definitely starting and stopping. Then a dancer is good for that. And try to keep my answers short here, but basically it's because of the inertia of the unwind. The inertia of the unwind is always going to want to stay stopped when you're starting the web, and it's always going to want to keep running when you're trying to stop the web. And a dancer accumulates that material and will feed out or suck in the start and stop and make it more consistent on the web while we're dealing with the inertia of the roll. Same thing with out-of-round rolls. Well, I guess it's not inertia. Out-of-round rolls, again, normally happens because of a clamp truck or the roll stored on its face and becomes out of round. When that rotates, the diameter effectively is changing and it's sending in speed changes into the process. A dancer is automatically going to be able to compensate because, again, it has this accumulation of material. It doesn't depend, a load cell will depend on the speed of the load cell, the controller, and the brake trying to respond to that. Where a dancer, the material automatically feeds out and the controller can take its time responding to it. So out-of-round rolls and indexing applications, and the last one would be if it's a simple machine. Sorry, Cris, no die cutting here, but if you're taking a jumbo roll and making a bunch of small rolls and we're trying to accelerate and decelerate at very fast speeds or time frames, dancers are key for that.
Great. So don't worry, Cris Slay, I have one specifically for you. This viewer wanted a little clarity, I think. They said, when Cris said wrapping the web around the anvil roll, does he mean having stripping rolls below the level of the anvil on both sides in order to push the material below the top surface of the anvil?
And actually, that would be optimal, yes, to be able to bring the web in from below the center line of the anvil roll on the infeed side, and to be able to pull it around the anvil roll and down to another idler on the other side. So if you could bracket the anvil roll in the center with two idlers that are lower in position, bring your web in, up around the anvil roll, back down to another idler and strip at that point, that would be optimal.
Okay. All right, we got lots of questions coming in today. So we do still have about 10, 12 minutes left in this session, so we'll get through as many as we can. This viewer says that they are seeing a higher number of web breaks on high-speed labelers using the 0.75 mil liner. Is it difficult to manufacture a die tooled to this liner gauge? Or in other words, have we pushed the boundaries too far on liner thinness?
We're on the edge. The problems in terms of consistency are exaggerated when you have to accumulate all of these variations and trying to get the 75 gauge or the 48 gauge to convert. At those thicknesses, 4.5 10,000ths or 7 10,000ths, 7.5 10,000ths of an inch thick, any type of variation that you have in your production has an opportunity to have a negative effect on it. Is it successful? Can we successfully do this? Yes, it's being done regularly. Is it full of problems? Yes, your operators, your machinery, maintenance staff, the tooling design and how it's run, everything needs to be optimized and maintained in an optimal condition in order to be successful with the 75 gauge or the 48 gauge liners.
Okay, great. So this viewer is also having a little issue. I'm hoping that maybe you can provide a little clarity. They're asking what affects the oozing of the adhesive after die cutting, and are there ways to control it?
What affects it? Well, there are a couple of different sides to this. So I'll get through this kind of quickly. And again, feel free to email me or call me and we can have a 20-minute discussion about this. What I talk about with operators is the toolbox that you need if you are running very aggressive adhesives, adhesives that want to flow out of the die cut or from underneath the label after it's been stripped. And there are tools that you can use for this. One thing is if the adhesive itself is oozy, like you stated, is this, why is it? Is it because of heat or humidity or some sort of atmospheric, some sort of tension issue where it's being wound too tight on the roll prior to you even trying to convert it? Or is it happening at conversion? After you die cut it, are you going through multiple idler rollers after the fact and allowing the adhesive, after you've die cut it, are you allowing that adhesive to migrate back together and then stripping later down the process to where you're having problems with it coming off? Rewind tension is the key here. If you have high rewind tension coming off your machine, if going to the slitter rewinders, if your rewind personnel aren't conscious about what they're doing with their tensions on the roll on the finished product, they can cause the adhesive to ooze out from underneath the label or to block onto the back of the liner when the next wrap comes around on top of it. There are a number of different issues that can affect it. And again, cutting a gooey, oozy, difficult adhesive is has the same sort of requirements that you need to bring to the game that you do when you're trying to convert thin film liners. Same sorts of issues. You have to have a different set of tools and a different set of attitudes when you're approaching the material.
Okay,
Yeah,
great.
and I would stack on that and say, when he says tension, if the oozing is happening because of tension, then absolutely it's going to be taper tension is going to be the solution to that. We definitely need to reduce that tension as the roll gets larger on your wind.
Okay, excellent. So as I'm looking through this, someone was tuning in from the airplane and had to drop out, but thank you both for your comments. And also there's been questions about how to view this after. It will be available at labelsandlabeling.com if you had to drop off because you're on an airplane. So this question, do solvent-based inks affect the life of flexible dies?
In my experience, the answer is no. The ink that you would have to be concerned about is not necessarily water-based or solvent-based as much as the whiteners that are in the ink or whatever is supplying the opacity to the ink. Those, especially when they're white or pastels, the double bumps of white inks and inks that have a very high opacity, these have whiteners in them, and those whiteners in most circumstances we would consider abrasive. And if you were to run without those inks versus with those inks, you'd readily be able to tell the difference in die life that you would get cutting through ink or cutting through a blank label with no ink.
And then what about some of the ways to test shallow die cut and deep die cut? How can you test that?
It gets difficult because you have to kind of branch this off and talk about testing die cut for a film liner or for a paper liner. For paper liners, it's really pretty simple because when you cut through the silicone barrier, you can use an ink stain test, and if your ink is pulling down into the pulp fibers underneath it, you can see that bleed through. That bleed through itself, or the extent of that bleed through, can tell you how heavy your die strike is. With film liners, it becomes much more difficult because you don't have that bleed through characteristic. Most people have focused on the snap test, where they are taking the material, cutting it off or holding it between hands and pulling on it rapidly and snapping it between them. Myself, I like to have the web under tension and put the pad of my thumb down on it, not my thumbnail, just the pad of my thumb, and see if where the die cut is, where I can see it, if I can stretch that. If I can cause the material to start to stretch a little bit, that's putting more pressure on that area than any peeler tip will. I'm also seeing a lot of circumstances in the last couple of years, and to get a little bit off subject here, but it's the same subject. Seeing a lot more circumstances where customers, your customers, are now converting from running paper liners to film liners, and they are using the dispensing equipment that they were using for paper liners, unaware of the peeler tips, unaware of the tension that they are running, and how those peeler tips and that tension affect even the way the labels are being dispensed. So all of these factors play into it.
Okay. So this question here, does the diameter of the stripping roll have to be equal or greater than the length of the label being cut?
I'm sorry, say again?
Sure. This question is, does the diameter of the stripping roll have to be equal or greater than the length of the label being cut?
That's interesting. I've never actually tried to build an equation on that. Bigger equals bigger. No, I don't know, because the stripping rolls are generally idlers. I don't know that that there is any correlation mathematically that I could put onto it to be able to give you a specific answer. Like, for example, my 4x6 label running 4 inches around, I want a 3-inch or a 6-inch or a 2-inch diameter idler on there. What I am seeing is that as customers become more attuned to this, that they are typically have a variety, at least two, a 1-inch or a 1.5 and a 3-inch, or a 1-inch, a 3-inch, and a 6-inch diameter roller, so that they can make those changes. Specifically, I don't have an answer to that, no.
Okay. And then this viewer is wondering, do all of the same rules for tension apply for running semi-rotary dies, or should we be running differently for this type of die cutting?
Cris, do you have an answer for that?
Hey, can you say that again?
Sure. They're wondering if all of the same rules for tension apply for running semi-rotary dies, or do they have to do things differently for that type of die cutting?
I would say they probably don't. Most of the semi-rotary, and we see a lot of it in the flexo world now, Mr. Harper, is, it's got the dancers on there because of that start and stop actuation that's happening in the die cut zone. So no, I don't believe that there's any specific requirement. The trick with die cutting and die cut size is stability. If you have too much tension and you're pulling the web through the machine, whether it is semi-rotary or not, if you're actually accelerating the material using tension, then your die cut length, the length of your labels, will be longer. If you do not have enough tension and you're bagging or not keeping tension going through the die cut zone, not running one-to-one with the peripheral speed of the anvil roll, then your labels are going to be smaller and you'll have other problems associated with that. Specifically to semi-rotary, I am not aware and have not seen anything in that circumstance. Mr. Harper, do you know anything specific?
Actually, I don't mind admitting, after this seminar, I'll have to talk to Mr. Slay myself, because I don't know what semi-rotary is. Once I better understand that, I can give you more of an opinion. So, I'll go learn something after the seminar today. Michelle, go ahead and mention that.
Give me a call and talk about it.
Yeah, sounds good. And I'm going to go to mention too, also my email will be at the end here. so we can have further conversations too if anybody wants to chat, email or phone. But yeah, I'll have to research that a little bit myself to better understand what's happening with the web. But if it's something that you said starting and stopping, it's possible that we might need to put a dancer in there.
Yeah. And then I think the next slide here is the contact details for both Cris and Cris. Yes, I want to keep this up maybe as we answer. There still are quite a few people here, and I want to make sure that everyone's getting all the questions answered that they've asked. We did have a follow-up to the Oozy adhesive remarks, if you guys don't mind kind of digging in on that a little bit more. Okay, great. Thanks, Cris. So this question says, with the Oozy adhesive, we sometimes find that the label face stock won't separate from the matrix. Do you have any suggestions for what to do when that happens?
The first suggestion is to get the stripping as close to the die cut as possible, so that you're using the blades of the die, whether it's a flexible or solid die, you're using those veins as a separator, if you will, and pulling or stripping off of the die if at all possible. That will solve that. The next circumstance, if that's not available to you, is to strip as close to that die cut as possible. The number of rollers, the number of idlers that you pass over the top of that web, or around even on the bottom, the number of idlers, the more times it goes over around a roller, the more ironing action you have, and the more you will compress the material and cause that adhesive to ooze out the side and to rebond with adhesive that it's been separated from. I'd like to follow up also on something. My friend Phil Taylor texted me and said, and he's a better printer than I am. I'm a good die cutter. He's a better printer. That solvent-based fluorescent inks can be abrasive. So the first question about solvent-based inks, I think that this kind of plays in with what I was talking about with the whiteners for those fluorescent inks, or the coloring agents that they use for opacity in those inks. I think that that's where most of that abrasion comes from. Did I answer your questions?
I think so, yeah. Let me just double check. I think there was, another advice from someone on here. I'm loving this chat function right now. Lots of really good feedback for you both. But this person says the other thing you can do with Oozy adhesive is to chill the roll before converting. Adhesive is a liquid and will flow less and harden when cold. So yeah, I believe
we talk about that when we talk about the toolbox in my longer explanation. If you've got chill drums on your machine, but if you have the ability to run multiple chill drums or to turn some of those drums off and on, always run all of the chill drums when you're running an Oozy or aggressive adhesive like that, in order to try to keep the temperature of the web as low as possible. This is also the case if you're running blank labels, even if you're not printing on those. If you're running in a machine in which you can actuate your chill rolls, the chill drums on there, in order to keep the material as cool as possible, please do that. That will help with the die cut ability and your ability to separate the waste from the finished product.
Great, great. And I know we've gone just slightly over, but I do want to ensure that everyone is very clear on the content. There's been a lot of great comments about how clear and helpful it was for them. But this viewer is hoping that you can explain again the situation of dished rolls. Why does that happen and how to avoid it? I think that was you, Cris Harper.
Yeah, so again, a dished roll is, just make sure we're on the same page here. Let's say I have a 30-inch roll diameter that I'm winding up to. The first 12 or 13 inches as straight as an arrow and everything looks good, and as the roll continues to wind, it starts to waver back and forth, and not only that, but the first 12 or 13 inches is now moving, and that's happening again because of those inward forces on the wind, where actually I think a dish is actually, the layers are tightening on themselves. So as they tighten, then the materials are sliding. So not only do you not get with starring and dishing, not only do you get a not straight roll, but you can also scratch the material or damage the material by wrinkling it. So that dishing again is because of the inward force. And again, it's because we're deforming the layers internally. And if we apply a taper tension on that wind, we can make that go away.
Great. Well, thank you guys both so much. Thank you for Maxcess and Cris. A lot of people are just commenting about how clear and helpful the information was. I certainly agree. If we didn't get to your question, please reach out to both Cris and Cris, who have provided their emails. Also, I do know that Maxcess will be available at Label Expo too. You can see them there if you have further questions maybe we didn't get to today. Also, again, you can view this on labelsandlabeling.com after this session ends. Thank you both for your time today. We really appreciate it.
Oh, no problem. It was a lot of fun.
Thank you. Yeah, for sure.
All right, and that concludes our webinar, everyone. Thank you for joining today.